welcome back to the mini machine shop. Sorry about missing the last 2 Fridays, but we've been having a heat wave here, and this is the first day I can actually open up the shop, turn off the air conditioner, and sit here. It's a nice breeze. It's 88, but it's comfortable. Then I've got too many irons in the fire. I've been working on the flame engine, gun stock, Tapmatic, do-it-yourself Tapmatic, so it's been coming along. New stool here, a gift from my neighbor. I guess he got tired of seeing me sit on those ugly wooden stools, but so thank you, Vic. I love it. What have we got here? Alright, so I'm going to show some engine progress here. Not much machining on it, but it's almost running. So I'll bring you over to the bench and show you that. And then I'm going to show you what I've got so far machined for the Tapmatic, and it's coming out pretty good. So, I've also got a little goodie eBay find. I had bought a long time ago that little miniature toolmaker's vise just for fun. Next thing I know, I'm using it, so I bought this thing. Don't know what I'm going to do yet, but let's see what happens. eBay, $25, free shipping, out of China. Opening it up for the first time myself here. I had no idea it was going to come in a box. Some burrs on this guy. Just file it down and clean this guy up, but there it is, huh? And I'm sure it's going to be greasy, right? Oh wow, Alan. Oh yeah, it's greasy. Yuck. Alright. I don't know what I'm going to do with it, but like I said, I didn't know some of the other stuff. That little miniature vise, wound up using it to make the stuff. Eesh. Come on. It is indeed greasy. Which way? Oh, that way. Gotta keep looking at the camera. Wow, nice. Nice surface, I'll tell you that. Huh. I don't even know how you use this thing yet, but it looks really nice. All the surfaces are ground. Oh, it's loose. Yeesh. Alright, just get the oil off of this thing. Oh, some scratches in there. But, I guess. Oof. Slide smooth. Oh man, somehow they machined that really nice. So, for what it's worth, kind of a kick here. I was looking at it and stuff, and there were some burrs just easy to remove. I'm not sure why burrs would be on an L. I can feel it on this edge. It was on the top, you could feel it, and now I could feel it on the side. There are a couple other edges, but and this was weird. What is that spot about? Yeah, I guess you can see it. I'm looking in the camera. It's like a welding mark. Strange. So, and there's none on the other. It only goes that far. I guess that's for the 60 degree. But I just went on YouTube because I don't know how you hold anything in this. So I went on YouTube and there's no videos. There's one video in another language of a guy opening this or showing it, but I have no clue how you do it. I can put it, I know, in the vise this way, lock it down. Right, how long is this thing? Put that down. It is, yeah, just under 3 inches, so I can hold it. But I don't know what you do when you're trying to put something in it to machine. Anybody know? Anybody got a video? Anybody send me a link? That's it so far. Managed to get it running. It ran for about 15 seconds and then quit. Let's see. And it's using the original timing too. Jeez, that's way up there. Turn that down a bit. I don't know why it ran and that won't. It's like trying. actually running. Keep turning over like that. That's right. Maybe it was more heat. Oh, something gave up. I think it got hot, huh? Yeah, it's warm. So it expanded. Secret is the piston. It's in the piston. Alright, you saw the engine sort of running, sort of not running. Two problems with it. One is this isn't closing good enough, and two, the piston to the cylinder wall isn't good enough. This wasn't drilled out, it was bored on the lathe, and that was the problem because it's just slightly funneled. You know, you can't get that. I do it with the compound, and even if I did it with the saddle, I know it's still going to be funneled. So what I did was I made a steel one, slug, and put lapping compound in there and just went at it with the lathe. And I finally got it really nice and smooth and straight. Then made a new piston rather than steel. It's made out of aluminum. Nothing was lapped or anything. This was buffed up. But I've got a perfect seal on this thing. It just slides in there so smooth. So that problem solved. Now, the way I did this design isn't working out. So I need to come up with a better way or figure out something here that'll get this thing to seal. But that's the progress on the engine so far. Once I have this solved, I'm pretty sure that this guy will be running without a problem. So, onward and upward. The Tapmatic, what everybody's been waiting to see, the do-it-yourself. Didn't show any of the machining because this guy changed over and over and over again. I've moved the print. I have a print. I haven't put it up on the website, but I've got all the dimensions and details to it. So this was made for the biggest collet I've got, of course, and these original designs that I saw where the two pieces come together, they had friction plates in there where it was just friction. I guess you use a spring to push it together harder, and I didn't think that was going to work. So what I decided to do was 1/4-inch ball bearings. Since they're 1/4-inch, 250, I used a ball driver, went in 0.125, 50%. So I didn't want them coming out of this piece. Boy, that sure doesn't look like it. Yeah, it is 50%, but alright. This is 80 thousandths, so what they're going to do is pop out of here, stay in here, and then these two pieces will spin. Otherwise, they're locked together. The original, when I first put it together and did it, I was just trying to make some fancy detail work, aesthetic looking, whatever, in the lathe, and of course the lathe caught it and pink, it broke free as it's supposed to, and the ball bearings completely came out and flew everywhere. So what I wound up doing was making a little cage guy that'll keep the ball bearings together and in place. So how this thing works is, that's a 1/2-inch 20 threaded area all the way down, and this guy is the spring piece that pushes him up against him because he's threaded in there. This guy I'll remake because I've got a C-clip on here right now, and I realize I don't need to do that. What I'll do is just don't machine this down. I'll have this be this exact size. That way I know this thing is perfectly straight too. Oh, and by the way, both these surfaces have been checked on the granite block, and they're absolutely square to less than 1/1000th. This was done by fly cutting these things. So where was I? Alright, so this will be remachined with just a shelf on it, and it'll stay centered. But what you do is this guy, pretty easy to make. This was fly cut too. This goes in here, and I've got a slot in it for a screwdriver, but for just to get it assembled. You can push your finger in there. And I need to go, I think I'm going to go to Marshall's and just get an assortment of 1/2-inch springs. Okay, so you have that together, and then you can, oh yeah, just pull it apart this way. I gotta pull it apart this way to get the ball bearings in there. So, alright, oh great, there we go. Always fun getting them into the cage. There's 2. There's 3. I'm not on camera here, I have to lean forward some. Alright, come on, get in there. There's that one, and one more to go. Don't lift the whole thing up. Why is this whole thing lifting? Come on. We've got one ball bearing left. There. In. And that's it. And so it does work. And by tightening that up, you can tighten up the spring and the amount of force it's going to take to break this free. There is a spring that goes down in here in the center, and a rod. I'll probably use a stainless steel. And I had bought these guys for Irwin off Amazon, $20. Put this in a collet. Just grabbed a tap for each to test, and they wobble like crazy. So this is absolutely not usable. So I'm back to the drawing board of figuring out what to use to make a tap holder on this. Oh, and the rod will have a groove or something in it and a set screw, so we can go in and out, and it rotates with this, and then when this breaks free, then okay. And on the other side, Travers Tool. Now I'll be demonstrating these guys. Travers Tool sent me a few taps, spiral taps here. Excellent, excellent, thank you. These two are generic, and he sent me, the company is, I don't know, WAMAWA, Yamawa, or these are generic taps, tells me, and they look really nice too. But this one, a ZELX space AL, is specifically designed to cut aluminum, and I did try it out, and it does an incredible job. Really easy, goes right through. So when I get the Tapmatic done, I'll be demonstrating these, and I'll also be wearing the t-shirt that he gave for this company, that goes with this company. So thank you very much, Travers. That is awesome. So onward. Oh, and the other thing is too, I'm looking in the catalog at these taps. I've been buying the Irwin taps off Amazon, and the price for them versus the price for this is basically the same thing. So I wish I would have been buying these rather than the stuff off of Amazon, because these are really nice taps. Alright, onward and upward. Forgot to mention that yes, this is the Tapmatic so far. It's not auto reverse or anything. I just made this so when I got to do something like build a mini pallet or something where I need to do a bazillion holes, I'll be set for it. But I did a long time ago on the mill just rewire in that front control box where the emergency stop switch is. I put a switch in to reverse the motor. You just flip the polarity of the motor and it's going backwards. I put it back, or took it out, because back then I had gears in the mill. I didn't have the little machine shop belt upgrade yet, and it was making some weird noises when he put it in reverse. So I figured, I was still new, didn't know if I was going to damage the mill or not, so I took it out. But well, once this is put together, I'll be putting the reverse switch back in.